So here's our introduction into transformations. Remember I said in class there's 4 different types. We have reflections, translations, rotations, and dilations. Okay, so let's start with what are transformations? A transformation is basically an operation that maps an original figure called the pre-image onto a new figure called the image. So our pre-image is what we're starting with, and our image is the final result. So a transformation has the ability to change the size, position, meaning where it's located, or orientation, the direction it's pointing. Here are our 4 types again. We have reflections, which we're going to talk about today, rotations, translations, and dilations. Now it's important to understand that the dilation, and I would circle this, this is the only type that changes its size. Everything else stays the same size, same shape. A dilation will change its size. So let's go to reflections. So a reflection is basically a flip. And we're going to take our shape and we're just going to flip it. Some of you noticed this in our classwork yesterday. So we're going to flip it over a line called the line of reflection. So based off whatever they tell us, okay, we then flip it directly over that line. Each point and its image are the same distance from the line of reflection. So every point, everything we're flipping is the same distance. Okay, the x-axis and the y-axis are the most common lines of reflection. And reflections, this is super important to understand, they will create congruent polygons. So when we reflect something, it's the same shape and the same size. So write that in. I'm looking to see that you write same shape, same size. So let's go look at what that looks like. If I were to have triangle ABC, okay, I'm going to reflect it in the x-axis. But first we need to plot A. A is 1, 6. I go to the right 1, up 6. I plot B, which is 8, 3, which means I go right 8, up 3. Then finally I have C, which is 4, 2. Now you're going to want to connect these points. Doesn't matter how you connect them, but you got to connect them, right? Normally you should connect alphabetical order A, B, C, the order that you plotted them. Now I'm going to reflect it in the x-axis, meaning this here, this line is my line of reflection. So I'm going to take my triangle and flip it over that line. So let's start with A. See this point that's getting bigger? I'm going to use this point. It is 6 up from my line of reflection. So that means I'm going to make it go 6 down. It's the same distance from the line of reflection. Okay, now when we label it, we're not putting A. We're going to put A prime. That's what that little asterisk is, A prime. So please write down that it's A prime. After I've done that, I'm going to look at B. B is 3 from my line of reflection, so I'm going to go 3 down. And then I label that B prime. I'm going to do the same thing with C. C is 2 spaces above, so I go 2 spaces below, and I label it. Now, if you connect your shape, if you take a look at it, it's the same thing, just flipped. It's like the mirror image. So then I can determine the points. So A prime is sitting at 1, but this time it's -6. B prime is sitting at 8, -3. And C prime is sitting at 4, -2. All I did was change the top or bottom, from top to bottom. Okay? Let's go see what this would look like with a rectangle. So we're going to start with J, just like we kind of did in our last problem. Start with the first point. I'm going to go right 2, up 1. Then I'm going to label it. As you put the point, label it from the problem. Then I'm going to go K. K was right 4, up 7. Put its label. Then I have L, which was right 7, up 6, and put its label. This makes a huge difference. Then I have 5, 0, oops, sorry. Let's put my point first and label it. Then connect, okay? So we have a rectangle right here, ladies and gentlemen. Now, look what it says. I'm reflecting in the y-axis. It's important to know that I'm now looking at this line, and I'm going to take my shape and flip it over. So I'm looking at how far my points are from this green line. So start with J. Always start with the same first point. This one's to the right of my green line. So, and it's 2 spaces. So now I have to go 2 spaces to the left of my green line. Now this is now J prime. It's no longer J. Okay. Then I'm going to go with K. K is 4 spaces to the right. So I'm going to make it 4 spaces to the left. Now I'm writing K prime because the prime is my image. Then L. L is 7 spaces to the right, so I need to take it 7 spaces to the left and label it. So some people like to connect as they're going. I plot all my points, and then I'm going to connect them, okay? So we need to find out the new coordinates. Let's find the coordinates of our image. J prime, J was originally 2 to the right, and I went to the left, so it becomes a -2, but the 1 stays put. I didn't go up or down. My K, I moved it to the left this time, so it becomes a -4, but my Y stays the same. L, it becomes a -7, and my Y stays the same. And then M becomes a -5, and my Y stays the same. I hope you're seeing a pattern of what happens and what's changing, because that's going to come back. Let's try this again. So let's plot our P, Q, and R. So P would come over here, -8, -6. Q is -5, -2. And finally, R is 2, -1. We connect our sides so that we have our triangle. I'm reflecting it. My line of reflection is the x-axis. So it might help to draw it, because then you're going to count how far is this P from that green line. Well, it's 8 spaces down, so this time I have to go 8 spaces up and label it. Then my Q is 2 spaces down, so I have to go 2 spaces up and label it. I'm sorry, P, I said 8, it should be 6. And then R is 1 space down, so I go 1 space up and label it. When I connect, if you notice, it's the same shape. It's just flipped, okay? Angles stay the same. Side measures stay the same. I'm just reflecting it like a mirror image. So since I went over the X, okay, I'm shifting the Y's. So my X's are going to stay, but my Y's change. My X stays the same, but my Y changes. And then my X stays the same, but my Y changes. If you need to pause or rewind, do that now, because we're going to go try a trapezoid this time. Let's take a look at our trapezoid. We have W, X, Y, and Z here, okay? So I formed a trapezoid, but where am I reflecting this? My line of reflection is the y-axis. So it would help if you took a highlighter and highlighted your y-axis, okay? I'm then going to take each point. My original pre-image is to the right, so my image should now be to the left, and I take each point. So my W is where I'm going to start. I'm going to move it to the left side, same distance from that line of reflection, and label it. Same distance, same distance, same distance. So as you do this, it's basically creating the same image, just flipped. The angles, the side lengths, those don't change. They stay the same. So I have new ordered pairs though. So I have -2, -3, -4, -1, -8, -2, and then -3, -7. Look what's happening. I went over the y-axis, so I'm not changing my y. My y is staying put. I'm changing my x. So you've done 4 examples with me. I want you to pause this. I want you to try this on your own. I'm going to be looking for the highlighting of the line of reflection. I need to see your pre-image labeled. I need to see your image labeled, and I need to see the new ordered pairs. So I hope you found a pattern, and this is the general rule, okay? When I'm reflecting, if I'm reflecting across the x-axis, my x stays, my y changes. If I'm reflecting across the y-axis, my y stays, but my x changes. So look at 11 and 12. This is applying it without a graph. It says triangle LMN, given these points. Vertices are your points. They're the corners where your angles are formed. Undergoes a reflection and has these new coordinates of L prime, M prime, N prime. What would its line of reflection be? Well, here's what I do. Let's look at my x value of L and my x value of L. They changed. Did my y's stay the same? They did. So let's make sure that happened on all of them. My M and my M prime, those x's changed, but the y stayed the same. And then in my N and my N prime, my x changed, but my y stayed the same. So since my x value changed, it's a reflection over the y. Okay? So look at this one. Remember what we're saying. If the x stays the same, but the y changes, I went over the x. If my y stays the same, but my x change, I go over the y. So whatever's staying the same is what you're reflecting over. Okay, think of mirror shows you what you're looking at. So what's staying the same? Okay, that's what you go over. So it wants to know which pair of points represents a reflection across x. So I'm going across x. My x needs to be the same, but my y change. So I can rule out A and I can rule out B. So I come down to C. So in C, both x and y change, but in D, only my y changed. Okay, so therefore, a change in the y while x stays the same is D. So I'm looking to see that you have this written down, plus anything else I've written. There's a lot I've given you today, and we're going to practice this. You have to be able to reflect, and you need to know that a reflection maintains the size and shape. It just changes its orientation and its position, but the size and shape stay the same.